What's up, everybody? In this video we're going to solve some exact differential equations. First of all, what is it and how does this work for us? Well, the first step is recognizing that this is an exact differential equation. And before that, sometimes you might see it like this. So you have like this equation with nothing on it, apparently. And then you have the second one which has the whole thing aggregated to it. But this is the same thing as this one, that you have both elements here separated. So if you have 2xy plus 1 and you essentially multiply everything by dx, so you're going to get the same thing. So dx, and then it's x squared plus 3y squared, and then dy dx, but then you multiply it by another dx, right? So you cut these two out, and because this is 0, so anything multiplied by 0, it's the same thing. So you'll end up with the exact same thing as the right one. So you have 2xy plus 1 dx plus x squared plus 3y squared dy equals 0. So just a quick note, because sometimes you see exercises and they have this in this form or in this form, just for you to be clear, because this is 0. So this is just another way of looking at the convention, right? So let's go about it and solve a simple example. So let's say this is the one that we're trying to solve. So how we solve this is naming this first element m, and then this second element n. You can call it whatever you want. This is just the convention. So m is equal to 2xy minus 3x squared, and n is equal to x squared minus 2y. So the way for us to first know if this is exact or not is to do the derivative, but in terms of the other term. This is what I mean. So for m, what we're going to do is the derivative, but in terms of y, and for n, we're going to find the derivative, but in terms of x. And the second one is the first thing. So we have this one, it's a constant, and we have this one. So all we have is 2x. So what this means is that both are the same. And if this is the case, we call these exact differential equations. And how we solve this is by first continuing with m, and then we're going to integrate the expression. So 2xy minus 3x squared dx. And the second one, we're going to do the same thing, but for y. So x squared minus 2y dy. So just going to solve both of these. So let's do that. So the first one, we can separate this one and this one. So we have 2 that comes outside. Then we have x, y, dx. And then we have minus 3 and then x squared dx. And if we continue, we find that this one, we have an aggregate y, so it counts as a constant. So we have 2 over 2 x squared, right? Because it's x goes to the second power divided by 2, which is this one. And then the second one is the same thing. So 3 and then x to the third power divided by 3. So the solution to this one is x squared y minus x squared plus, and then we call the constant in terms of the other one, so cy. For the second one, it's the same thing. So it's going to separate this into separate integrals. So dy, and then minus 2y dy. So this first one, this is a constant, so it comes outside, and we have y. And then for the second one, we have 2y squared divided by 2. So these two cancel out, and we are left with x squared, y minus y squared, and then the constant in terms of the other one, so cx. So the solution to this is a function fxy equals c. So we have this first term and we have this first term. And the first thing to look for is similar elements. And we can see that we have this one here that is exact same as this one. So what we do here is just keep one of them. It sounds a little bit weird, but this is how this works. So we keep one of them, so it's x squared y, and then we keep the remaining part as is, so minus x to the third power, and then minus y to the second power, and that is equal to c. So this is your solution.